We've now looked at how we can configure various diagram elements that we've added to the P&I diagram. In addition to configuring the elements that we add, the control panel, device, function elements and things like that, we can actually configure the simulation itself. The way you do that is you get the simulation into edit mode, you get PISim rather into edit mode, so you click the edit button, you move the editing cursor to white space on the P&I diagram and then right click, and you can see that comes up with configure. Now this is the simulation configuration menu, so if we click on that one, it gives us information about the things in the simulation that we can configure. So in this case, we can configure the nominal flow rate through the system, top valve steady state position, bottom valve steady state position, levels in tanks, and the cross-sectional area in the tanks. And this simulation lets us check time constants as well to make sure the values we're entering will produce a reasonable simulation. In addition, you can do some configuration of test variables. Now these are used in the simulation history, but really the configuration that you can do here is really just setting these values to allow you to calculate the test parameters, ISC, IT, AE, things like that. Okay, so the parameters that you can actually adjust in a particular simulation are completely controlled by the simulation designer. So in the case of this tank, it's a relatively small number of parameters. What we've got 7 parameters that can be configured. Other simulations will have a lot more parameters, so if we actually look at the continuous start tank one, this one here, and we have a look at the configuration page for that, you can see that we actually have stream data configuration, we have equipment data, reaction data, physical properties, and also we have data from the configuration design tool. The C-star simulation is so complicated that to set the thing up at steady state, you need to run an Excel tool that does the steady state balances for you and works out what nominal concentration should be. PISim will run without that information, but it won't start at a steady state. And because the C-star, the exothermic C-star, can actually be unstable, you might have a lot of problems setting up a control scheme if the thing doesn't start near a steady state in a relatively stable condition. Okay, so obviously the more complicated the simulation, the more of these things you actually have to deal with, but it just gives you a bit of flexibility in running your own simulations or as an instructor actually setting problems for the students. Thanks for listening.